Right now, the most advanced lightning-fast AI models in the world systems that can process millions of data points in a second, they are waiting on something, well, incredibly low-tech to function.
Yeah, they're waiting on trenches.
Ye-
Copper wire, concrete.
Welcome to the Deep Dive. If you're joining us today, we take a stack of complex sources and try to map out the hidden patterns underneath.
Right.
And today we're unpacking two analytical notes documents titled Civilization Analysis and N10 Thesis. And our mission today, right here with you, it isn't just to hand you a list of facts.
No, I mean, facts are easy to come by.
Exactly. The goal today is, well, it's a cognitive shift, a sort of controlled drift in how you perceive the friction in the world right now. Because you look around, and it doesn't really feel like the world is breaking.
No, it's not stopping.
But something isn't flowing.
It's clogging.
It's clogging. And to understand why, we have to look at today's sources a bit differently.
Right, because the author explicitly describes this work as an observation device. We aren't really looking for neat, resolved conclusions here.
Right, no clean answers.
No, we're being asked to look for pressures, gradients. It's a structural framing of the world.
Well, let's start with what we can actually see, the intuitive observations. Because if you look at the news, or honestly, just look at your own lived reality right now.
Yeah, trying to buy a car.
Right. Trying to buy a car, dealing with huge delays on a construction project, or, noticing rolling power supply shortages, it just feels chaotic.
It does.
The sources map out these really specific phenomena, things like stressed power grids, persistent port and logistics delays, uneven semiconductor distribution.
And that intense concentration of GPUs and data centers.
Yeah, all of them trying to pull resources at the exact same time. And on the surface, they look completely unrelated.
Right. You see a local power issue, a shipping delay, a tech hardware shortage.
And that's exactly how they're treated, right? Like isolated fires. It feels like playing a giant game of whack-a-mole.
Oh, absolutely.
You read a headline about a port delay and you think, okay, that's a supply chain issue.
Right.
You read about construction costs and think, oh, that's an inflation crisis. We look at them as separate, localized problems.
But they're happening together.
Happening together.
And this is where the structural framing really comes in. What if we stop looking at the individual crises and start looking at the structure beneath them?
Like, what if they aren't individual problems at all?
Exactly. What if it's the exact same structure?
You mean they're just surface-level symptoms?
Yeah. They're symptoms of the same limit. They're happening simultaneously because they are all hitting the exact same invisible wall.
Okay, so if it's all the same wall, which one is it? What is the structure we're actually hitting?
It is a limit of how much can flow.
How much can flow?
Right. And to grasp the mechanics of this, we have to unpack a concept from the text called the civilization stack.
The civilization stack.
Yeah. It maps out how human progress is structurally built. Because civilization doesn't just exist in a void, right? It's built in layers.
Like building blocks.
Exactly. And each layer rests incredibly heavily on the one beneath it.
Okay, so let's walk through this stack. It starts at the absolute base layer, right?
What begins with the planet.
The physical Earth. The raw geology, the minerals, the atoms.
Yes, the planet. And sitting directly on top of that is energy we extract from the physical planet to generate power.
Okay, so planet, then energy.
Yeah.
That makes intuitive sense. You can't do anything without the raw power to activate it.
Exactly. And this is the crucial one, sitting directly on top of energy is infrastructure.
The infrastructure layer.
Yeah. The pipes, the wires, the roads, the concrete, the deep water ports, the power grids.
And this is where the illusion happens, I think. Because for most of us, this infrastructure layer is completely invisible.
Oh, totally.
Just background wallpaper. You flip a switch, the light comes on. You turn a tap, water flows.
You click order, a box shows up.
Right. We only ever notice infrastructure in the exact moment that it fails.
But everything passes through it.
Every single thing.
Every physical good, every electron, every piece of data, everything. And because everything passes through it, the source makes this really vital point. Infrastructure is the layer that dictates capacity.
Capacity.
Yes. It determines the absolute physical limit of how much can be supported.
It decides exactly how much can flow.
Right. And only once you have that infrastructure can you build the next layer, which is AI, the digital realm.
And on top of AI.
The state, governing bodies, laws, social organization.
Okay, and then?
And finally, resting on all of those layers combined is civilization, the actual society we experience.
Wow. So planet, energy, infrastructure, AI state. Civilization.
That's the stack.
When you lay it out sequentially like that, the vulnerability is just, it's glaring.
It really is.
The higher layers are entirely subordinate to the lower layers. Like, you can write the most brilliant, highly optimized AI algorithm in human history. But if the local grid transformer, the infrastructure, if that's maxed out, it doesn't run.
No. The computation is strictly bound by the concrete.
Bound by the concrete.
And that physical dependency brings us to the core crisis in the text.
Yeah.
It's an issue of asymmetry.
Asymmetry.
Yeah. We have a massive fundamental gap in speeds. The text calls this a gradient.
A gradient between demand and capacity.
Exactly. Think about the demand side right now. Demand is accelerating.
Because of AI. Massive new data centers, the transition to new energy grids.
Right. The demand for power and logistics is curving sharply upward. It's nonlinear.
It's exponential. We need massive amounts of computation today, and we'll need, orders of magnitude more tomorrow.
Demand is exploding, but infrastructure is not.
Infrastructure is not.
No. Infrastructure can only grow linearly.
And that's the gap.
That is the gap.
Okay, but I have to push back on this a little bit because, look, I get that pouring concrete takes time.
Sure.
But surely capital markets adjust for this. If ports are clogged, if grids are maxed out, isn't that just a massive financial incentive to build more?
You would think so.
Right. I mean, trillions of dollars are flowing into AI right now. If data centers need power, why can't companies just buy their way out of the linear constraint?
Because the physical world fiercely resists capital.
Oh.
Yeah. Money can move at the speed of light. Code can be deployed globally in an instant. But concrete cures at the speed of chemistry.
That is, wow. That is a brutal reality check.
It's the defining conflict, the gradient between the speed of money and the speed of matter.
So the bottlenecks aren't financial at all?
No, they are deeply physical. Say you want to upgrade a regional power grid to handle a new AI data center. You need massive high-voltage transformers. You can't just throw $1 billion at a screen and spawn one.
Right, it's not a video game.
Exactly. There are only a handful of factories on Earth that can wind that specific gauge of copper at that scale.
And I imagine the supply chain to even build a new factory to make those transformers is backed up.
Of course. You need specialized steel. You need to mine the materials. It takes a decade to permit a new copper mine.
A decade.
Yeah. You have to physically dig the trenches. The capital is there, but the capacity of the physical world to absorb that capital, it's maxed out.
The physical world has a strict speed limit.
And we are pushing right up against it. Exponential demand colliding head-on with slow, linear physical capacity.
So let's look at the mechanics of that collision. When exponential demand finally hits that linear wall of capacity, what actually happens?
Well, it's tempting to think things just snap, right?
Right, like the grid melts down, the supply chain explodes, society halts.
But systems don't fail first. They don't just snap and stop.
They clog.
They clog. Civilization isn't collapsing from some sudden destruction. It's wearing down.
It's wearing down from friction.
Exactly. Not a stop. More like friction.
It feels exactly like trying to upgrade an old computer to handle a massive new workload.
Ah, that's a great way to look at it.
Yeah, like you download the most demanding software possible, but you're running it on a 5-year-old motherboard.
Right.
The software wants to pull data instantly. The processor asks for maximum power, but the physical traces on the board can only carry so many electrons.
I mean, what happens to the computer?
It doesn't blow up, it just gets incredibly hot, and then it throttles. Every single process lags.
The mouse cursor stutters.
Exactly. You try to open a basic text file, and it takes 10 seconds. The entire system is desperately trying to manage the heat and the friction. It doesn't stop, but it's not really flowing either.
That is the perfect mechanical representation of what the text calls chronic structural stress. When a global system reaches its absolute maximum capacity, it loses all of its elasticity.
All its slack.
Right, it throttles. And we are so used to having slack in the system. Empty space, margin for error.
But when that margin disappears, small, localized delays suddenly ripple out across massive areas, which is exactly how the gradient functions in the real world.
Exactly. A single ship waiting outside a port means shipping containers aren't returning to Asia.
Which means a factory in Taiwan can't load its new semiconductors.
Which means an automotive plant in Germany has to halt production because they're missing one chip.
Which means the local dealership down the street from you doesn't have the car you want to buy. The system is technically still running.
Still running.
But no margin.
Zero margin.
And because there is no slack, every tiny disruption creates a massive shockwave, We haven't broken the world. We've just lost the empty space. Every system is running at max capacity.
And this brings up a really profound shift posed by the source material. It forces us to ask a difficult question about how we perceive our current era.
Okay.
When we look at the immense activity happening globally right now, the frantic building, the tech investments, are we actually watching growth?
Oh, is this growth?
Right, or are we merely watching the disappearance of slack?
Are we just consuming the final reserves of our capacity?
That's the tension. Are we growing, or are we just filling up the very last bit of margin left in the system?
Because it's so tempting to look at technology and assume it'll just fix it.
Mm-hmm.
Oh, AI will optimize the grid. It'll route the logistics.
But technological speed and physical infrastructure speed are not synced up.
AI can instantly generate a brilliant blueprint for a power grid.
It can solve the logistics math in seconds.
But it cannot instantly pour the concrete.
It cannot.
It cannot lay the copper wire.
No. And the thing about limits is they are almost never observed until you bump right up against them.
Right, you don't feel the limit of the cooling fan until the processor starts to overheat.
Precisely. The unseen limit remains invisible until flow is restricted. The source urges you, listening to this, to fundamentally change your metric of progress.
Because we're conditioned to ask, how far have we advanced?
How much faster are we going?
But the question for this era is entirely different.
We need to start asking, where are things starting to clog?
Because the clogs are the true map of our reality now. They show us where the physical capacity is maxing out.
The demand for flow has permanently outpaced the physical space to flow through.
How much can still flow?
Maybe we've already reached the limit.
So to you, listening to this right now, I want to encourage you to apply this structural lens to your daily life. Because once you see the gradient, you really can't unsee it.
You really can't.
The next time you experience a bizarre delay on a package, or a rolling blackout, or a system that just inexplicably struggles to perform a basic task, don't brush it off as a random glitch.
It's not a glitch.
It's civilization pressing its face right up against the glass of its own structural capacity. It's the motherboard throttling. Nothing is broken, but something is absolutely no longer flowing.
And if we connect this framing to the most personal level, it leaves us with a really uncomfortable perception to sit with.
What's that?
Well, we've spent this time mapping out global infrastructure, right? The power grids, the shipping lanes.
With the macro systems,
And we've established that they're operating with zero margin for error.
zero slack.
Right. But think about your own life as a micro-civilization.
Oh, wow.
You have your own personal stack, your time, your energy, your financial buffer, your emotional bandwidth.
Your personal capacity.
Exactly. If the massive global systems we rely on every day are fully clogged, constantly sending out these shockwaves of friction, what happens to our personal buffers?
If the macro infrastructure is throttling, how much can still flow through you?
Right. What invisible everyday infrastructure in your own life is currently running at maximum capacity?
Maybe we've already reached the limit there, too.
And if that is true, what happens to your personal system when it receives its next minor disruption? Are you growing, or have you too simply lost your slack?